Hello everyone, welcome to another video of General Science of Class 10, and today we are going to see how to draw ray diagrams for spherical mirrors for formation of image. So before we move on to how the diagram actually works, what we are going to see is how to actually start drawing and what are the factors or what are the terms that we need to know beforehand before we move into drawing the diagrams. So the first thing that we need to know are a few terms. So let's draw a rough sketch, a very rough sketch. I'm going to draw here. Suppose this is the mirror and we have a principal axis. This is a line that goes through the middle of the mirror. This strikes, or that I've drawn right now, or stripes you can say, which I've drawn right now behind the mirror, shows that this part is the reflecting part and this is the painted part. Okay. Now then we have 2 points here. One is mentioned as C, one is mentioned as F, and this point here is called P. And these are the basic things that you need to know. Now what are C, F, P and this long line? This line first of all is called the principal axis. It is the line that goes, it acts as the axis of the mirror. So it goes to the center of the mirror, passes to the center of the mirror, and this acts like the stage over which the whole performance will take place. So whenever you draw any object, that an object has been placed in front of a mirror, the object is always placed on top of the principal axis. From here we will draw the rays of light will come, they will reflect, they will come, they will reflect, they will form the image or whatever. The whole process will go on, but it moves or happens along this principal axis, this line. The principal axis cuts the mirror. This is our mirror. This curved structure is our mirror. Okay, now it cuts the principal axis at a point called P. This P is called the pole. So the pole is the point where the principal axis and the mirror meet. The principal axis and the mirror meet at pole. Okay, now as we have said, the mirror is a spherical mirror. So spherical mirror means this mirror is a part of a sphere. So every sphere has a center, right? So this center is marked here as C. So it is the center of the sphere of which the mirror was a part. What is a spherical mirror actually? A spherical mirror is a mirror in a sphere. It has been cut out. A part of the sphere has been cut out, which now acts as the mirror. So what we have done here, C, is that when it was a sphere, obviously it had a center. That center will be chosen as the center of the mirror. So this point C is called the center of curvature. Okay, it is called the center of curvature. Now this is called the focus. F here stands for focus. Focus is basically the half the length between center and pole. So this is the length between center and the pole, and half of this length is from the focus to the pole. Okay, so the distance between center and pole is called the radius of curvature, or basically you can say it is the radius of the mirror. Okay, and the distance between focus and pole, it is called the focal length. Okay, and focal length is half of the radius of curvature. I hope this part is clear now. So now we have known all the points. Let's move on into the diagram of how to draw the mirrors, the ray diagrams. So what we're going to do, we're going to start off with concave mirrors. Okay, now how do concave mirrors look? What do concave mirrors look like? Obviously they are spherical mirrors, so a sphere. Now always remember, in a concave mirror, the side that is bulging inside, the side that is going inside is the reflecting side, and the side that is bulging out is the painted side. So if this is the mirror, suppose this is a spherical mirror, this part will be the reflecting side or the shiny side, and this part will be the painted side. So this is going to be a concave mirror. On the other hand, if this is a mirror, this is the painted side and this is the shiny side, which will be act as the mirror, then it will be a convex mirror. So now we are going to deal with concave mirror, where the side that bulges out will be the painted side. So how to draw diagrams for these types of mirrors? So there the diagrams are based on the position of the object. So when the object is placed at a certain position, how does it, where does it form the image, what is the nature of the image, what is the size of the image, everything we are going to see. Okay, so first of all, the first condition is when the object is between, I mean not between, when the object is at infinity. Okay, when the object is placed at infinity, what happens? So let's draw a diagram. This is our mirror. We have our painted side. What we need to do, what you will do is take out a scale and draw a line that passes through the mirror. So this point becomes the pole. Okay, now what you will do, when you drew the mirror, when you will draw the mirror, you will take a compass. Okay, never draw it freehand. I am drawing it freehand because I don't have the resources here. Take a compass and draw the mirror. So whenever you take a compass and draw the mirror, obviously the compass is going to be placed at a certain point on your paper, with the radius that you are going to take for drawing the arc or drawing the mirror. That point will be your center of curvature. Okay, where you place the pointer of the compass and draw the arc, that point is going to be the center of curvature. So suppose this is our point, which is the center of curvature. Okay, now what you will do, you will take the scale, you will measure the distance between center and the pole. So what you will do is you will measure this distance. Okay, then after measuring the distance, suppose it comes out to be 6 centimeter, take exactly half of that, which will be 3 centimeter, right? And there draw another line, which will be our focus. Okay, so we have got our 3 points, C, F and P understood. I hope you have understood how to draw this. Now what we will do, we will take, or we will think as if, as I have written in the heading, that object is at infinity. Now when the object is at infinity, you cannot, suppose I want to draw the image, I cannot draw the image object here, because the object is placed at infinity. Infinity means you cannot see where the object is. So what you will do, we will assume that rays of light are coming from the object and hitting the mirror, and they will reflect to form the image. So that is what we will assume. So we will assume that it is coming from infinity, from somewhere it is coming, it is hitting the mirror. Okay, what we have done here is we have drawn a ray of light which is parallel to the principal axis. This is our principal axis. We have drawn a ray of light parallel to the principal axis. Now why we have drawn, or why we have selected a ray which is parallel to the principal axis? Because a ray of light may be parallel, may not be parallel, because when an object is there, light comes out in every direction. So what we will do here is we will choose a selected few rays which are beneficial for us. I mean beneficial, by beneficial I mean which makes it easier for us to draw the diagram. Okay, so if you draw a ray of light which is parallel to the principal axis, what happens is after reflection, it will pass through the focus. So this makes it easier for us to draw the diagram, because we know exactly where the ray of light is moving. So it will pass through the focus like this. Okay, done. Now we don't know where the head of the image is, where the tail of the image is, because it is at infinity. So what we are going to do, this is actually the easiest diagram. What we are going to do is we are going to take the scale again, and we are going to draw another ray of light which will be again parallel to the principal axis, but this time from below the principal axis. So suppose the ray of light has come like this, it has entered, it has reflected, and again as it was parallel to the principal axis, it will move through the focus. Okay, so in order to form an image, two reflected rays must intersect. So here after reflection, the two rays intersected at this point, and it is the point at focus. Okay, so if an object is at infinity, the rays of light after reflecting will intersect at the focus. So as it is formed at the focus, and you can see it is formed right on top of the principal axis. It is intersecting at the principal axis, right? It is not above the principal axis or below the principal axis. It is right in the middle of the principal axis. As a result, what is going to be the nature of the image? The image formed will be a point image. It is a point image. Okay, Where is the image formed? Image is formed at focus. And what is the nature of the image? What is the size of the image? As it's a point image, the size of the image will be highly diminished. Highly diminished. And it will be real. Now, what do you mean by real image and virtual image? If the image is formed in front of the mirror, it is a real image. If it is formed at the back of the mirror, it is a virtual image. Keep it as simple as that. No need to complex things up. Okay. If an image is formed in front of the mirror in the real world, then it is a real image. If the image is formed at the back of the mirror in the virtual world, then it is a virtual image. So here the image has been formed in front of the mirror, therefore it is a real image. So these are the properties of the image. Okay, that's a diagram where the object is placed at infinity. Let's move on to our next diagram, and our next diagram will be when the object is between infinity and center of curvature. So how do we draw this? Again, we have a mirror. We take our scale, we draw the principal axis, really important, principal axis. We take, again, you will do this all based on the measurement. Okay, don't draw anything which is not measured, otherwise there are going to be few diagrams which you can't even match if you are not having the correct diagram. Okay, then here we will draw an object, because now we have said the object is between infinity and center, means it is not an infinity, it is somewhere between this point center and the infinity. So what we are going to do is we are going to draw an object here. Okay, suppose the name of the object is A for the head, B for the tail. Now we have to draw a ray diagram. So first diagram, as I have said, as I have done in the last one, we will draw a ray of light which is parallel to the principal axis. Here it goes parallel, and as I have said, after reflection it will pass through the focus. So any ray of light which is parallel to the principal axis after reflection will always pass through the focus. Okay, always pass through the focus. Done, right? Then we will have another ray of light. We have to draw another ray of light. Now this time the object is placed on top of the principal axis. So what we will do, we will choose a ray of light which passes through the focus. See what happens. Okay, we will draw a ray of light, incident ray of light, which passes through the focus. Here is a ray of light that passes through the focus. Now after reflection, what will happen? So as I have said in the previous one, a ray of light parallel to the principal axis after reflection passes through the focus, and a ray of light which passes through the focus after reflection becomes parallel to the principal axis. Okay, it is just the opposite. So after reflection it will become parallel to the principal axis. So let's draw the ray. After reflection it becomes parallel to the principal axis. Okay, so now what happens? The rays of light intersect at this point, so the image will be formed here. So this will be A dash and this will be B dash. So see, the head was here and the reflection took place here, so the head will be formed at the bottom. Okay, that's why the image here is ulta, inverted. Okay, inverted image has been formed. So what are the features here? First of all, where is the image formed? It is formed between center and focus, between C and F. Then it is diminished in size. The size has become smaller. See, you can check. Look at the size of the object and look at the size of the image. The size of the image is smaller than the size of the object. Next, we need to see whether it is erect or inverted. Here the image is inverted, so we will write inverted. And whether it is real or virtual, obviously it is real because it is formed in front of the mirror. Hope you got this. These are the features. Okay, now every diagram we are going to follow almost the same step. Let's do it. Number 3 is going to be a diagram which is very important, because here the object is at C. Now why it is so important? Because in order to draw it correctly, you need to have the perfect measurements. If you don't have the perfect measurements, it will never match. So draw We'll draw the principal axis. We have the center, suppose here, and focus here. We'll have the pole here, and now we have to draw an object. So our object is going to be at C. At C. So now again we are going to follow the same method. We are going to draw a parallel ray. Going to draw a ray parallel to the principal axis. As we know, after reflection it will pass through the focus. Okay, this is not right. After reflection it will pass through the focus. Next we will draw a ray of light which passes through the focus, and of course after reflection it will become parallel to the principal axis. So now we will draw a ray of light which passes through the focus. After reflection it will become parallel to the principal axis. Okay, now see what has happened. As I have not done this diagram with proper measurement, where is the image formed? See, the image will be formed here, right? But this is wrong. Why this is wrong? Because when the object is at C, the image is also formed at C. So where should the image should have been formed? It should have been, I'm sorry, the image should have been formed here. Okay, so because of lack of measurement, the image has been formed in the wrong place. So that's why I am telling you, whenever you draw this diagram, make sure that the diagram is properly measured. The center must properly measure, the focus must be measured properly, the rays should be parallel to the principal axis. So if everything is done correctly, then only it will meet. So in this diagram, this should have been formed here. Okay, so that's what happens. So in this case, what is going to be nature? The image will be formed at center. Okay, image will be formed at center. Size will be same size as the object and the image. What is the nature? Obviously it is inverted and real. Let's draw the next diagram. Here is our principal axis. I'm drawing it freehand, okay, so that you can just get the idea of how to draw. This time we will place the object between center and focus. So again, a ray parallel to the principal axis will obviously pass through the focus, and a ray that passes through the focus after reflection will pass through the principal axis. Okay, this diagram is not right. Okay, let me do it properly. Let's draw this. Let's take our scale. We'll draw a principal axis. Let's have this as our center, then this will be our focus. If this is the object here, let's see how to draw parallel ray. It will obviously, as we know, pass through the focus. Then a ray which is passing through the focus, as we know, what will happen to it? It is passing through the focus. So after reflection, it will be parallel to the principal axis. So where is the image formed? The image is formed here. Okay, so if this is AB, this is the A dash B dash. So where was the object now? The object was between center and focus. Okay, so as the object was between center and focus, it has been formed between center and infinity. Formed between center and infinity. So what are the nature? So first it is between image is between center and infinity. The size has been magnified. See, the object is smaller and the image is bigger now. So size is magnified. And what is the nature? It is inverted and real. Okay, move on to the next one, number 5. This time we will place the object at F. at focus. What happens? Let's see. Okay, object is at F, so if we draw our center here, suppose this is our center, suppose this is our focus. So what we will do is we will place the object at the focus. So again we'll start drawing our diagram. So first one is going to be parallel ray, and then it will pass to the focus. This is not general, as we have done it throughout. Next, in our other diagrams, what we had done is we had drawn a ray of light which will pass through the focus and then become parallel. But here we can't draw a line which passes through the focus because the object itself is on focus. So what we will do? This time we will draw a ray of light which will pass through the pole. Okay, a ray of light that passes through the pole. If we draw this ray of light that passes through the pole, what happens is the angle formed here, after reflection it will form the same angle and come out. Okay, so you'll use a protector and measure the same angle here so that it comes out like this. Okay, so these two angles, this is the angle of incidence and this is the angle of reflection. These two angles should be equal, okay, making the same angle. So here is our incident ray, reflected ray, incident ray and reflected ray. Now look at the reflected rays. These reflected rays are parallel rays. So parallel rays will never meet. So it is assumed that these rays will meet at infinity. So it is just the opposite of the first diagram. When the object was at infinity, the image was formed at focus. Now when the image is at object is at focus, the image will be formed at infinity. See how it has become a cycle? It is just the opposite. So what happens to the nature of the image? Nature of the image will be at infinity. So as we don't know what is going to be the size, means when it will meet, so it is assumed that the size will be highly magnified. Highly magnified means it becomes very big. Okay, and finally it is going to be a real image. Okay, and yeah, it will be inverted, of course. Okay, so real and inverted, these are the features. Let's move on to the last one of concave mirrors. In the last one, what do we have? Object between focus and pole. So in this diagram, what happens? This is a different diagram from the rest because here we are going to form a virtual image. The only case in the diagrams of concave mirror that we are going to form a virtual image. So C, F, P. So suppose here is our object. Again, diagram process is same. Parallel ray, passing through the focus. Then we have a ray of light which passes through the pole. And as I have done in the previous diagram, if it passes through the pole, it will make the same angle and come out after reflection. So it happens something like this, right? So it will come out like this. Now the thing is, after this reflection they will never meet in this direction because these are divergent rays. So how to make them meet? It is assumed that they will meet somewhere. They must have come from a point behind the mirror where they were meeting. So if we just go back and trace the lines backwards, if we just trace the lines back, we will see that they will meet at a certain point. So let us trace it back. If we trace it back, both the lines, they will meet at a certain point. Now where do they meet? Let's check that. See, they meet at this point. So this becomes the point of formation of image. Now this is a virtual image because it is formed at the back of the mirror. So if this is AB, this is going to be your A dash, B dash, the only case where a virtual image is formed. So what is the nature of the image? Obviously it is formed behind the mirror. The nature is position is behind the mirror. What is the size? Size is obviously magnified, as you can see here. Size is magnified, and it is erect, means it is straight, and it is virtual, not real anymore. So that's all we have for concave mirrors. For convex, we have only one diagram, and we are going to see it right now. So for convex mirrors, so what type of a diagram will we have? The mirror will be like this, where this part is now painted. Okay, so what happens in case of a convex mirror? This is our principal axis, of course. Now this time the focus and center of curvature are going to be towards the right hand side. Here we are going to have the focus, suppose, and then this is going to be the center. On the left hand side there is no curvature. It is curved this way. So obviously the focus and center will be on the right hand side. So let's place the object somewhere. Wherever, we can place the object anywhere because there is no position related to this. Okay, now we will take same thing, parallel ray again. Now this time after reflection, what should happen? It should pass to the focus, but it can't because there is no focus on this side. So when it reflects, what happens is, what you do, you take the scale and you connect it with the focus and the point. Okay, this, it will actually reflect like this. Why? Because when a ray of light parallel to the principal axis moves, it reflects back in such a way that if you trace it back, it should meet the focus. Okay, that's a property. A ray of light in a convex mirror, which is parallel to the principal axis, when it reflects back, it reflects in such a way that it passes through the focus. Okay. Next, we are going to draw a ray of light which will be at the pole, directly at the pole. It will have the same property, it will be having the same angle. Okay, at the pole means it will make the same angle and come out. Now again we are going to do the same thing. We are going to trace it back because they can't meet on this side. So as it moves on this side, here our image will be formed. So if this is the object, I'm sorry. Here it will be like this. So if this is AB, this is going to be A dash and B dash. Okay, that's how we draw for convex mirror. Very simple diagram. Anywhere you place the object, the image is always going to be formed here. Okay, so what are the properties? Formed between pole, this is the pole, between pole and focus of image is formed. Size is obviously diminished, and it is real, virtual, and erect. Always, all the diagrams, any diagram you draw for convex mirror, you are going to get this sort of result. So that's all we have for today. We have drawn 7 diagrams, 6 for concave mirror and 1 for convex mirror. I hope you have understood. I hope you now understand how to draw ray diagrams, practice them properly and with proper measurements. So thank you everyone for watching, and until next time, cheers.